everyone for showing up today and joining the webinar. The topic today is testing web applications with Spring Framework 3.2. And we'll start off with a little bit about ourselves, today's speakers. First up, my name is Sam Brannen. I'm a Spring and Java consultant at a company called Swiftmind, which I founded a few years ago in Zurich, Switzerland. I've been developing Java for over 15 years, and I'm also a core committer for the Spring Framework, where I've been basically the test lead since 2007. I'm also a certified Spring trainer and a presenter on topics such as Spring, Java, OSGI, and testing. Our other speaker today is Rossen Stoyanchev, who is a full-time employee at VMware and a core Spring committer, where he focuses basically on a lot in the web tier, so Spring MVC as well as Spring Webflow, and he is the main developer of the Spring MVC Test Framework, which will be the second half of this presentation today. The agenda for the day basically has two main sections. To start off, I'll go over some of the new features and updates to the Spring TestContext Framework, so basically the integration testing support in Spring. And then for the second half, Rossen will introduce the Spring MVC Test Framework and show you how to use it. At the end, we'll follow up with some question and answers. So first up, updates to the Spring TestContext Framework. Some of the new features, some background information on dependencies. We've upgraded to JUnit 4.11 and TestNG 6.5.2. With TestNG, you'll just get new features with TestNG. But with JUnit, one of the things to note is that JUnit as of 4.11 has changed its dependency on, or actually how it incorporates, the Hamcrest core matching library. So now that is an optional dependency from JUnit, so you can now control which version of Hamcrest you want to use when you're using JUnit 4.11 and also with Spring TestContext Framework. A new main feature we have in Spring 3.2 is the ability to load a web application context for your integration tests, and we'll talk about that more in detail. We'll also talk about how this new support makes it easier, or basically enables you to test both request and session scoped beans. Then we'll talk about support for using application context initializers within integration tests. And last but not least, we'll talk about support for loading context hierarchies, which will be added in Spring 3.2.2, so not 3.2.1 as stated here. And there are some more features that have been added in the 3.2 timeframe in Spring's testing support. We won't get into all those details, so if you want more information, please see the presentation that Rossen and I gave last fall at Spring 1.2GX 2012. If you need information on that, you can contact us via Twitter or follow our Twitter feeds and see links to that. So, loading a web application context in an integration test. How can I tell the Spring TestContext Framework to load a web application context for me instead of a standard application context? Well, the answer is pretty straightforward. All you have to do is annotate your test class with @webappconfiguration. So what is this @webappconfiguration? It's a new annotation we introduced in 3.2.2, and basically it just denotes that the application context that's loaded for your integration test should in fact be a web application context. And again, that's in contrast to a standard application context, which would otherwise be loaded. Now, in the background, what this is used for, other than just to say that you want a web app context, is also to configure the resource path for the web app. So basically the base resource path for looking up resources in a web application. So if you think about a WAR file, when you deploy a WAR, you're going to have resources within that WAR file, such as images, CSS files, maybe some XML files, or configuration files underneath the web folder. And some of your components might need access to this, and these are obtained via the servlet context, so loading resources via the servlet context. So in an integration testing environment, you use typically something like the mock servlet context from Spring, and this mock servlet context will be configured for you by default in the background by the Spring Testing Framework. And the default location for this root resource path is source main web app. So if you're familiar with Maven directory structure for web applications, then you'll know that source main web app is the folder in your project that you use to store things like your images and HTML files, etc. So again, this source main web app is a file system based resource, and it's relative to the project root. So anytime when you specify just a path with @web app configuration, this will be relative to the project root. So typically, well, basically the root of your JVM. And if you're starting a test with your build, for example, with Maven, or running a test in your IDE, this will be relative to the root of your project. In addition, so I mentioned that by default, this path will be from the file system. However, you might want to pull this from the class path. So if you want to do that, all you have to do is use the class path prefix, and that will instruct Spring to load or basically set the resource path as a path in the class path. And now we'll take a look at a few examples on how to configure all this. Here we have an example with the defaults. So we have a web application test class, and it's annotated with @webappconfiguration with no attributes. And by default, as I mentioned before, this will tell Spring to use or to load a web application context for you for your integration test. And the root of the resource path will be, as you see in the comments, from the file system, a relative directory, source main web app. In contrast, the @context configuration annotation will look up things from the class path if it's looking up an XML file. So for example, it could potentially auto-detect a file with the same name as the class, so in this case, WAC tests or WAC tests, and then adding a suffix to it, -context.xml. And this would be searched for in the same package as your test class. The other option is to use a nested static @configuration class if you prefer to use Java config instead of XML files. But again, the thing to point out here is the difference between the defaults. So with @web app configuration, the default is from the file system, and with @context configuration, the default is from the class path. Now let's take a look at another example. Here we are supplying values for both of these annotations, and again, just want to point out what the default semantics are. So here we have @web app configuration with web app as the path, and again, that would then need to be a folder in relative to the root of your JVM. So for example, relative to the root of your project when executing your tests. And then we see with @context configuration, if we have a path like this, /spring/test servlet config XML, this would need to be a file that's present in the class path, where Spring is a root folder in the class path. And last but not least, for this comparison, in order to contrast here, we're now overriding the defaults. So with @web app configuration, again, the default is file system based, so we can override that by saying class path : and then we're specifying a path in our class path that should serve as the root for resource lookups in the web application context. And on the flip side, with @context configuration, we're overriding the default of a class path lookup with the file : prefix, and then we're specifying, for example, here, source main web app, webinf, and then servlet config.xml. So this could, for example, be the production configuration of your servlet config XML file that you're using in a Spring MVC application where you're following the Maven directory structure. So for example, source main web app being the root of your war. So that's it for the basics of @web app configuration. Just some information on what's going on behind the scenes that makes this support possible. If you are familiar with the Spring's testing support, the Spring TestContext Framework, you might have heard of the basically this interface test execution listener, which is an SPI that you can implement to provide additional functionality to your integration tests. And by default, there were previously 3 of these from Spring, and now this is a 4th one. This new one, the servlet test execution listener, is basically responsible for setting up the web support for loading the web application context. And it does this by setting up state in Spring MVC's request context folder before each test method executes. What it does is it creates a few mocks for you in the background. So it creates a mock for the request and a mock for the servlet response. Again, these mocks are from the Spring test module. You can use them standalone, but these are created for you by default. And this execution listener also creates a servlet web request. Beyond creating these mocks, it also makes it possible for you to inject these mocks into your test instance. And we'll see some examples of that in a few minutes. And of course, as you would expect, after your test executes, after the test method executes, this listener makes sure that the thread local state for that request context holder is cleaned up appropriately so that you don't have any conflicts when you're running subsequent tests. And again, this servlet test execution listener is configured by default, so you won't have to explicitly configure it, but it's good to know that it's there in case you want to somehow tweak it or extend it. Now, I mentioned that you can inject these mocks into your tests. So here we have a test class, public class WAC test, so web application tests. It's annotated with @web app configuration and @context configuration. And then we see the various web artifacts that we can inject into the test instance. The first one is @autowired web application context WAC for short. So we can actually inject the web application context that was loaded for our integration test. The next line we see that we have the mock servlet context, which can also be injected. And these two lines have comments behind them stating that these elements are cached. And what that means is that the Spring TestContext Framework will automatically cache your application context across the execution of test methods within the class, as well as across the execution of test methods within your test suite. For more information on this, I recommend you check out the context caching section of the testing chapter of the Spring reference manual. Now, we see also that we can inject, for example, the mock HTTP session, the mock HTTP servlet request, and the response, as well as the servlet web request. And we'll take a look at a few examples of these in the coming slides. So the next topic is web scopes, but first a quick review. So if you've been using Spring for a while, you're probably familiar with concepts such as singleton scope and prototype scope, but you might not have heard of the web scopes. So Spring has supported web scopes for several years. Basically, there's two types, so two additional scopes, request and session. If you have a bean that is set to have request scope, then its lifecycle is tied to the current HTTP servlet request within your web application. Similarly, if you have a bean that is configured to have session scope, its lifecycle will be tied to the current HTTP session within your web application. So we'll take a look here at testing these things. One quick note is that, as I mentioned before, Spring has supported these two scopes for web applications for several years. But in the past, it was somewhat difficult to test them on your own. And now with this new web application loading support and this servlet test execution listening that runs in the background, it's now actually pretty easy and straightforward to test a request scope bean or a session scope bean. So let's look at some examples. Here we have an example using JUnit, so JUnit's annotation @runwith, and then basically specifying or telling JUnit to use the Spring JUnit for class runner. So that says use the Spring TestContext Framework to run an integration test. And then we see the two annotations from Spring we just talked about in the previous slide, so @context configuration and @web app configuration. So we know that a web application context will be loaded for this integration test, and we can inject beans from that context, as well as for example, the mock request, which we see here. So we have @autowired user service, which is our subject under test, basically the component we're trying to test. And as we'll see in the next slide, this user service has a dependency on a request scoped bean. So in order to test the user service properly, we need to make sure that the request scope bean is properly configured for the current request. And the way we do that is we inject the mock request into our test instance. And then we see here in this public void request scope method, with this request, we can, for example, set parameters in that request. So we set parameter user to Enigma, and then we set the basically request parameter password to Spring. And then we can actually invoke, for example, this login user method on the user service, and assuming or knowing that the login user method uses a request scope bean in the background that actually needs this user and password request parameter, then we know that we can actually test our code as we would expect, and then assert some results afterwards. So this is how you would test. Basically, inject the subject under test, inject the mock request, configure it, and then invoke your method that you're actually trying to verify. And now for the configuration, we see here we do in fact have a user service bean, and it takes as a constructor argument a reference to a login action bean. And now if we look at the login action bean, we notice three things. First up, we see on the fourth line that the scope is set to request. That means that this will be a request scope bean. But what you must not forget is the next line. So this nested use of the AOP namespace. Here we're saying AOP scoped proxy, and that instructs Spring to make sure that a proxy is created for this bean, and that every other bean that needs access to this bean will actually get a bean for the current request as new requests come in and new requests are executed. The third thing to note is the use of the Spring expression language. So we see with the constructor arguments for username and password, we see this format here, hashtag, curly brackets, and then some expression. Here, since we're running in a web application, we have access to the current request object. And from that, we can actually pull out parameters. So we can invoke request.getParameter user and request.getParameter password. If you look back on the previous slide, you would see that these are exactly the two request parameters that we configured in the mock request in order to integration test our component, our user service component. Now moving on, beyond request scope beans, we can do something similar for session scope beans. In this case, the configuration at the top is exactly the same. We are again injecting our user service with @AutoWired, but this time instead of the request, we're using @AutoWired to inject a mock HTTP session. And now if we look at the public void session scope method, we can see that we're actually using this mock session. So session.set attribute theme, and for this example, blue. So basically we're saying we know that our user service needs to have the theme attribute set in the session. And then we can invoke the process user preferences method on the user service, and again assert some results. So in our actual bean, we'll see that the theme is somehow retrieved and/or set. In this configuration here for the example session script bean config, again we have the user service, and again it takes a constructor argument, but this time it's a reference to a user preferences bean. And if we look at user preferences, the second bean, we see that it also has a scope defined, but now it's scope equals session instead of scope equals request. And again, we can't forget to use the AOP namespace to ensure that this is a properly scoped proxy. Then for the constructor argument, so the third line there, C:"theme, we're basically setting the theme constructor argument to the value of this Spring expression language expression. So again, this hashtag, curly brackets, and then some expression. Here we're accessing the current session in the web application and pulling out the theme attribute from that. And again, if you look at the previous slide, the theme attribute was what we set in the session in order to properly integration test our user service component. Next up, we have application context initializers. So this is a core feature. This is not necessarily a testing feature, and it was introduced in Spring 3.1. Just a bit of review. Basically, what it's for is programmatic initialization of a configurable application context. So somebody programmatically configure your application context as opposed to a add configuration class or an XML file. It comes in before those things are loaded. And you can do this, for example, to register property sources or activate profiles against the environment abstraction in Spring 3.1 as well. Now, typically, you would do this in a web application directly within WebXML by specifying the context initializer classes attribute or variable there. And that can be set, for example, at your root web application context via the context loader listener context param. And you can set that for the dispatcher servlet via an init param. Now, that's just kind of the background of when you could use an application context initializer. One thing to think about is that in the past, so in Spring 3.1, it was able to use them, or you were able to use them in a web application context, but you weren't able to test it with the integration testing support in the Spring TestContext Framework. So now, in Spring 3.2, we actually can use these initializers in our integration tests. The way we do that, here we again have an example with JUnit, but the important thing to note is that the @context configuration annotation has a new attribute. You see here initializers equals to, and then it's passing in an array of classes that are your custom initializers. So here we have a property source initializer and a profile initializer. A few things to note about that. As I mentioned, these initializers and tests are configured via the new initializers attribute. By default, these initializers are inherited from parent classes. So if you have a class hierarchy within your test classes, you can use this functionality. And if you wanted to override that, you could set inherit initializers to false in order to turn off that inheritance. Another thing to note is that in the past, you had to supply either XML resource locations or annotated classes, for example, configuration classes, in order to load an application context for your integration test. But now, with the support for initializers, it could be that you have a custom application context initializer that's responsible for configuring the entire context. So you may no longer need to configure resource locations and or annotated classes. Another thing to point out here is caching. So these initializers are also taken into consideration in order to define a unique context cache key for your application context. In other words, if you define different initializers but the same configuration files, those will be seen as different application contexts from the Spring testing framework, and they will be cached separately. In terms of the order of execution, you get the same behavior here that you would in production. So if you are using application context initializers in a web application and deploying them, they will be invoked in the same order in your integration test, specifically following Spring's ordered interface. So if you implement the ordered interface, or if you annotate your initializers with @order, these will be taken into consideration. And the next topic, application context hierarchies. So up until now, when using or when writing integration tests with the Spring TestContext Framework, there was only support for flat, non-hierarchical contexts. So basically, you could define multiple files to be used to load an application context or multiple configuration classes, but you still just had one application context. You couldn't have a parent-child relationship. And it was actually somewhat challenging to basically create context with parent-child relationships and then test them. But the downside, right, is that hierarchies are in fact supported in production. Most commonly in a Spring Web MVC application, you'll have a root web application context as the parent, and then you will have a child application context for your dispatcher service, so for your Spring MVC configuration. And since you're using that in production, it would be nice to be able to integration test that, right? So we agree, and in 3.2.2, we are adding support via a new @context hierarchy annotation that will be used in conjunction with @context configuration. So basically, you can nest @context configuration, as you know today, within @context hierarchy, and we'll see some examples in a minute. Another thing to note is that @context configuration has a new name attribute, and the only reason you'd want to do this is if you want to somehow merge or override the configuration at various levels within your context hierarchy. And for examples on that, there'll be a blog post coming up in a couple of weeks that will explain that in more detail. And if you're interested, we can provide a link later on for the Jira issue that shows some examples for that as well. So here we have a simple example. We have a single test, as in one test class that's not in a test class hierarchy, but it configures a context hierarchy using the new @context hierarchy annotation. And then we see here it accepts, this annotation accepts an array of @context configuration elements. And here we see the first level would be a parent context using parent.xml as a config file. And we see a child context using child.xml as a config file. Now, you're not limited to XML. You can, of course, use Java configuration here as well if you want. But the thing to note is that basically two application contexts will be loaded. There will be a parent and a child. These will both be cached. And the child application context will have its parent set to the parent application context. So you can test configuration similar to what you have in production. Here we see probably a bit more fleshed out example. Let's assume we have a web application that has configuration for the root web application context in this first file here, this source main web application context.xml. So that's the root web application context configuration, and we could declare that as in this example, an abstract base test class, abstract web tests, and then we can have some concrete subclasses of this. So we see here two. We have one for testing our SOAP web service configuration and one for testing our REST web service configuration. Each of these classes extends abstract web tests, which means that the parent application context will be the root defined in abstract web tests. And then locally, using @context hierarchy, we're basically telling the Spring testing framework we want to have a hierarchy. And at this level in the hierarchy, we want to use, for example, in SOAP web service tests, /spring/SOAP ws-config.xml. And similarly, for the REST web service tests, we want the child configuration to be loaded from /spring/REST ws-config.xml. So what happens at runtime when you run these tests is that you will actually have 3 application contexts. You'll have the parent, and you'll have 2 child application contexts. And each of the child application contexts will reference the parent, and these will all be cached as you would expect. And that's it for a basic overview of the new features in the Spring TestContext Framework and web application testing support. Now I'd like to hand over to Rossen to talk about the new Spring MVC Framework test support.
Thank you, Sam, and welcome to this webinar from me as well. In the second half of this presentation, we'll be talking about the built-in Spring MVC testing support, which is now included in the Spring Framework itself. Until version 3.2 of the Spring Framework, we have actually never included dedicated support for testing Spring MVC applications, for example, controllers. And the typical testing scenario until now has been to write pure JUnit tests, perhaps relying on the mock HTTP servlet request and response, passing them into controller methods as necessary. Of course, that leaves a lot that remains untested in the Spring MVC layer. In particular, we have configuration, and we also have annotations on the controllers that actually do quite a bit. Lots of things like data binding, type conversion, validations, and so on. Things that you will just have to assume that they will work at runtime. We have request mappings and so on. So there's tons of things that need to be tested. And that's the purpose of this dedicated support that we now provide. And as you will see, that's using a Fluent API. So it's very easy to write these tests. In fact, the experience with the Spring MVC Showcase until version 3.2 of the Spring Framework was that we just didn't have any tests. And as a result of this new support, it was now quite easy to add some tests that are pretty comprehensive, and they ended up uncovering a few issues. So I guess that was a pretty good validation of the value of these kinds of tests. In short, there's no really reason now not to write proper tests for Spring MVC applications. And the support that we'll be covering includes both client and server-side support. Server-side support includes, obviously, Spring MVC controllers serving requests. The client side is for code that's using the REST template, the ability to do that in your tests to set up some expectations and expected responses without having to have an actual live server on the other end. And for both of these, there's no servlet container requirement, so these tests should be, generally speaking, quite fast and easy to execute inside your development environment. A little bit more detail. The code that we're talking about is included in the Spring Test module of the Spring Framework, and that's something that you probably are already familiar with if you're using the mock HTTP servlet request and response objects, but also the TestContext Framework, which Sam talked about. Certainly, the new additions in 3.2 that Sam covered, including the support for loading web application context as well as context hierarchies. Both of these are very important for testing web applications, and we build on that in the Spring MVC test support. And also we use the mock request and response objects, which is why we generally don't require a servlet container for these tests. These server-side tests involve the dispatch of servlet. The main significance of that is that the processing that you will have during tests is generally the same as what you will have at runtime, except running without a servlet container, but using the mock request and response objects instead. And the client-side tests involved the REST template. Just a little bit of history, and perhaps a lot of you are wondering about the specific versions of the framework where this can be used. In general, all features discussed in this presentation are available in version 3.2 of the Spring Framework, which has been available since last December, currently at version 3.2.2. But this support, the Spring MVC testing support, actually evolved as a standalone independent project on GitHub, and you will see the link provided here on this slide. And that project developed before 3.2 became available, and it is still available, actually. The main reason for that is if your project is still working against Spring Framework 3.1, then you can use that project on GitHub and begin using it today with 3.1. However, if you've already upgraded to 3.2, which should be a drop-in replacement in any case, then most certainly look to the Spring Test module of the Spring Framework. And without any further explanations, let's take a look at an example. In general, I will not be showing too much code in this presentation. It would be quite nice, of course, to do some live coding as well, but there are lots of examples that I will provide, and the best way is to just look at these examples, and because we have a Fluent API, you can use code completion as well to uncover a lot of the features, but I'll try to provide a bit more context and a bit more background that you cannot perhaps get from elsewhere. So the example that you see here, we are loading our servlet-context.xml, which in this case presumably is on the class path, but it could be located on the file system next to WebXML and so on. And then we're injecting that with the auto-wired annotation, that whole Spring configuration, into the test fixture. And in the setup method, we're going to create an instance of a MockMvc class. This is the main class for the server-side testing support. And as you can see, in this case, we're doing something very simple, where we're just referencing our web application context configuration and requesting that to be built. And this is using a builder style option, and there are lots of other methods that we will see a little bit later on that you can use, but this is the simplest possible setup that you can have. And then in the actual test method, you will see that we're using this MVC instance to perform a GET request for a particular URL /foo in this case, and then passing along an accept header for application JSON content, and then defining certain expectations on the response, including a response status of 200, a specific content type of application JSON, and we're also using here JSON path, which is a separate library, third-party dependency for inspecting the body of the response. This is actually very useful for working with XML and JSON responses. We have support for XPath to be able to assert very specific things in the body. That's something that would otherwise take quite a bit of code if you were using Java objects. Just a side note on the usage of the Fluent API that we have here. In order to have this Fluent API, you'll actually need to import a few static methods. Generally, the easy way to remember that is if you search in the IDE for all classes that start with MockMvc, so MockMvc wildcard, those are going to be classes that contain potential static methods of interest. In fact, you can just import with .star, and you'll have everything available. And one more tip here for Eclipse users in particular, that if you go into the Eclipse preferences, you will find a section where you can define favorite static members, and you can add these types there, which will make it easier for you to use control space in the source code while you're editing this so that way you won't have to go up and type the static import before you can use it. So just a recap of what happened with the server-side test, what we saw there. We actually loaded our Spring MVC configuration, which means that what we're testing here is not only the code, but the actual Spring MVC configuration, making sure that whatever we've got in there actually works. We are using an instance of a mock HTTP servlet request. That's what's being created under the covers. And that means no dependency on a servlet container. It's not required to run that. And we're executing that through an instance of the dispatcher servlet, which ensures that the kind of processing that takes place, the full life cycle of a Spring MVC request is going to take place just the way it does at runtime. And then we're applying a variety of different assertions on the resulting mock HTTP servlet response. So if you take these 4 bullets, that should give you a mental image of what's going on under the covers, and that should help you to understand and answer a lot of questions that you might have in the process. One common question that tends to arise is around terminology, whether this can be considered integration or unit testing. This is actually a very good question to consider at this point. On the one hand, we are using a mock HTTP request and response, and we're not using a servlet container, so that would seem to put us closer to unit testing. But on the other hand, we're using an actual instance of a dispatcher servlet, and we're loading the actual Spring MVC configuration, which means that there's a lot more going on than simply creating an instance of a class and unit testing it. So as a result of that, I would say that while this is not full end-to-end testing, in other words, this doesn't replace the need for something like Selenium to verify what happens in the browser, the point is that you now have much more complete test coverage of your Spring MVC web layer, and by the time you write Selenium tests, you can be quite confident in how your server side is going to respond and the functionality that's there, so you can focus on testing the client side. And of course, there is a degree of overlap. You know, if you're writing Selenium tests and if you're writing Spring MVC tests, you might say, well, you know, I may just write Selenium tests. That's fine, although I think that the strategy of having separate Spring MVC web layer tests is a good one. And it's one that tends to work well, and it's similar to having dedicated database integration tests when you focus on testing the database layer separate from other layers. So in short, if I can answer the above question here, let's say that Spring MVC test is dedicated integration testing for Spring MVC. But of course, at the end of the day, these are just terms, and there's no need to get too much caught up in them as long as we understand the principle. So if I can then summarize a possible strategy here for testing using this framework, is that you can focus on testing the Spring MVC web layer alone, which means that you can continue to inject controllers with mock services or mock database access objects or database repositories. And if you're imagining this with the Spring configuration being loaded, you may have a question at this point, which is how would we actually inject the controllers with mock services, considering that we're loading the Spring configuration, which loads controllers, that in turn loads our business services and so on and so on. Wouldn't that just automatically load all of our dependencies? How can we get the mock services into that picture? And I'll answer that question on the next slide. But basically, the idea is that we're going to thoroughly focus on testing Spring MVC, including code and configuration, and we're going to do that separate from lower-level integration tests. So while we're developing our web application, we can quickly run tests when we make changes to the controllers and see the results. Now, in terms of injecting our controllers with dependencies, what we'll have to do is we'll have to declare mock dependencies in our Spring configuration. and that way we can ensure that these mock dependencies are what gets injected into the controllers. So for example, if a controller depends on a database access object called foo DAO, you can see here a snippet of XML configuration that relies on the Mockito framework using the factory method mock to prepare a mock instance of that particular instance. And that now can be injected into a Spring MVC controller. And of course, you'll want to replace the part of your configuration which loads the business services or the database services with these dependencies, so that way those are the dependencies you're going to get during test time. And then the other part of this picture is the ability to the next step, which is necessary, is to inject one of these mock instances into the test class, and that you can do with the auto-wired annotation. And then in one of the JUnit methods, like @before, @test, or @after, basically you can set up or reset the expectations on that mock instance, and that's how you can basically work with this. What can you actually test? Assuming that you can execute easily requests against your Spring MVC controllers, how much is actually taking place and how much is being executed, considering that we have @response body methods, considering that we have possibly a model in view with view technologies and so on. In general, the first things to focus on testing are things like the response status, the headers, and the content. These are the things which are available in the mock HTTP servlet response. And those are the things which are visible externally to any client. So I recommend focusing on testing those first as a good practice. But sometimes it is necessary to test additional things. If you want to verify some very specific things, it might be better to get directly at them to explicitly demonstrate in the test what it is that you expect that will happen. And this is where the Spring MVC test support shines, because we're doing this internally within Spring MVC, we can actually keep track of the model in view, the flash attributes, and other server-side only concepts that we can actually inspect and verify. So for example, we can test what is the content of the model, what flash attributes were created. We can prepare some input flash attributes, what session and request attributes are available. We can also verify things like which controller method the request was mapped to, what kinds of interceptors were there any exceptions raised and resolved using a handler exception resolver, etc., etc. However, I would again caution to use these options sparingly and to focus on testing the first bullet item above, the response status, headers, and the body of the response first, and only if it is necessary to verify something very specific, then to use these as well. Because ultimately the end result is what we're focused on here. The assertions on the response body can provide, there are various options there for JSON and XML. You can use JSON path syntax or XPath syntax, XML unit for comparing the content of XML, and various parts of the API have ham-crest matchers available for use, so that gives you quite a bit of leeway in terms of verifying the response in different sorts of ways. What about the view layer? If you're using view templating technologies, will that work? In general, all of it should work. So if you have free marker, velocity, time leaf, if you're generating JSON, XML, PDF, Excel, all of that should work as expected. Generating the content to the body of the response. However, one notable exception here is Java server pages. Because we're not using a servlet container, there is no JSP compilation and there is no JSP execution. However, what you can do is you can assert what JSP page was selected or what JSP page we forwarded to. That's how far it goes. And then if you're doing any redirecting or forwarding from the controller, once again, that's not something that's supported because there's no servlet container. But you can assert what URL we redirected to and what URL we forwarded to. And if you think about the fact that we're using the mock HTTP servlet response underneath, that will kind of make sense. Also of interest when we talk about the view layer is the HTML unit and Selenium driver integration, which is a very, very small, thin integration that's already fully functional, but will need a little bit more work. That's why I've put a little comment there that it's experimental, but it is available as a project, as a separate project, sort of an extension to Spring MVC Test. And if this is something that interests you, in other words, writing tests using the HTML unit API or the Selenium API, where the server is actually an instance of MockMvc, and then please check it out. Your feedback there will be quite valuable. One useful option for debugging. Very often what you will maybe run into is that you will write some tests and then perhaps you will not get the expected results. You might feel tempted to do some debugging or see what's going on. Just about the easiest thing you can do is insert a line with a print statement as shown here in this code snippet. And this option will print for you all possible details that you could get by doing debugging. You will get the content of the mock HTTP servlet request and response. You will get the mapped handler controller method. You will get any exceptions that were raised and handled, and so on and so on. So just insert this and look at the console for the results. There is one other option that I can mention, which is called the standalone setup. So when you're building an instance of MockMvc, there is an option where you don't have to load any Spring configuration. The idea here is that we're going to be focusing on testing one controller, an individual controller instance at a time, which feels a lot closer to unit testing. However, we're still going to be using the dispatcher servlet. We're just not going to be pointing it to any Spring configuration, and we're just going to give it an instance of a controller instead. And here is an example of what that looks like. Here you will see that we're using the standalone setup builder, and we're simply giving it an instance of a person controller, which is a controller class with the typical @ request mapping annotations and so on. And that's pretty much all we need to do. Then we can start using it as usual. And the thing to point out here on this option versus loading Spring configuration is that in general, loading Spring configuration is the better option because it tests your both your configuration and your code. However, if your Spring MVC setup is quite straightforward, and you prefer this style of testing where you focus on one controller at a time, you can see the advantages here because this test makes it very clear what it is that's going to handle this request. You can directly inject the controller here with Mockito or EasyMock object, and it's just a much more focused style of testing. However, again, the downside is that you're not testing the Spring MVC configuration. And there are different ways to approach this. For example, you can write a bunch of standalone tests, and then you can write a few tests that actually load the Spring context and make sure that that works as well. Certainly for getting started, for doing a quick test, this is going to be very handy to have. It is possible to use filters, and along with the mock HTTP servlet request and response, we also have other mock objects, including a mock filter chain. These are all in the mock package of Spring Test, various implementations of the servlet API. So what you'll see here is an example of building a MockMvc instance, and then along the way adding filters. We are adding a couple of filters in this case, and then we're performing the actual request and looking for the result, which would have been as a result of using one of these filters. And while we're talking about filters, it's relevant to mention that one of the main use cases that we considered when adding this support, filters in particular, is support for Spring Security. And this is something which is going to be done in a very easy to integrate way. The Spring Security Framework is going to provide that support. However, even ahead of that support, it is possible to do already. And I would look to the Spring Security project. There's already some sample tests that you can find there that will demonstrate how you can do this today. And there should be upcoming support there that will make it very easy to combine Spring MVC Test support with Spring Security. One thing that comes up very often in writing these tests is that you have some shared request properties. So, for example, every time you, for example, have a JSON being served from a controller, then every time you have to say accept media type application JSON. And to avoid repeating that, during the setup portion, you can provide the definition of a default request, and the properties of that default request are going to be used in all of your tests. So wherever we use the MockMvc instance prepared this way, when we try to create a request with it, it's automatically going to be merged with those properties. And then the same thing applies to expectations. So for example, on every test, we may want to assert that the result is status of 200. If that's the case, you can say always expect, and you can provide any number of these and have them reused across all of your tests. Just one extra note here on the semantics of all that. When we're setting up default request properties, they're going to be merged with requests that you define, which means that your individual tests can override request properties. Whereas with expectations, these are expectations that are always executed, and that's reflected in the terminology of the method names. One more thing that you may need to know at some point, which is handy, if the Fluent API doesn't give you everything, if you need to get to the underlying request and response for whatever reason, you can append this method and return at the end, which will give you back an instance of the MVC result. And then all of the accumulated results from the tests are going to be provided to you. You can access them directly and then use them in whatever way you see fit. And also I should mention that wherever you use static methods, if you want to add some additional methods of your own, for example, if you have additional ways to assert the response, it's quite easy to add them and plug them in. Obviously, it's just a static method. And if you have suggestions for such methods, feel free to also submit us some pull requests or put some tickets in Jira, make those suggestions, and help to make this better. Finally, an example of a client-side REST test. What you'll see here is an instance of a REST template being created and then passed into a mock REST service server. That's the main class for the client-side testing. What this class does, first of all, is it configures the REST template with a custom client HTTP request factory that allows it to store expected request properties, as well as store responses that should be provided when those requests are made, which means that you can set up any number of requests and responses, and then you can use the REST template in your code, and those expectations will be verified along the way as you use it. And then in the end, you can run the verify method to make sure that all these expectations were actually executed and met. So just to recap what happens with the client-side REST testing, we are creating an instance of the REST template, which we're going to be using in our tests. Perhaps it's in our client code. And that's going to end up being configured with a custom client HTTP request factory used for testing purposes. And that will allow us to record expected requests and also to set up the responses that should be returned. And then we can actually use the REST template in our tests. And finally, the verify method allows us to assert all the expectations that were that were set up were actually executed. And just a quick acknowledgement that the Spring MVC test support draws inspiration from a similar test framework in the Spring Web Services. Obviously, there's some similarities, but there's also quite a few differences. But the inspiration for the Fluent API and some of the ideas actually come from Spring Web Services. There's no shared code, obviously, but the ideas are there. Finally, some resources on further resources on Spring MVC Test. We have quite a bit of that. First of all, the reference documentation in the Spring framework has a chapter now which explains Spring MVC Test and what's available in detail. So do take a look through there. Hopefully that will be useful. And then, of course, the best way to learn is to look at some sample tests. And some of the framework's own tests are written with that in mind to demonstrate how to use the framework in different ways. So follow these links and take a look at those tests. And then also, as I mentioned before, the Spring MVC Showcase itself has full coverage for all of its controllers. So there's quite a bit of tests to look at there as well, including some Spring Framework 3.2 specific functionality, like async processing, for example. And then some more general resources on the Spring Framework itself. We have the homepage, as well as there's reference manual and Javadoc to take a look at, forums in Jira, and the source code on GitHub. A couple of blog sites to keep in mind, blog.springsource.com, where you'll find a few posts about Spring Framework 3.2 release, and then also the team blog of Swiftmind, Sam's company. And finally, we'll open up for Q&A questions. Sam, if you have any questions you've already identified, feel free to jump in, and I will take a look to see if there's anything I need to answer. I see one question about HTTP versus HTTPS. We are using, this is server-side testing, so this is within the boundary of the servlet container. We're invoking directly the dispatcher servlet, so there's no actual HTTP request being made. There's no HTTP library, so therefore there's no HTTPS necessary per se. This is already on the server side. We're making a direct invocation into the dispatcher servlet. And a similar comment can be made about file uploads. There is a way to perform a file upload. However, because there's no actual HTTP request coming in, we're not going to be parsing the multi-part request. Instead, we're just going to set up a mock multi-part HTTP servlet request, which contains all the various parts of the multi-part request. So once again, this is just one step further on the server side. This is not a client-side test which is going to fire an actual HTTP request to hit the server. This is already on the server side that all of this testing is being done. So we're just setting up a mock request and response. And I mean, it does help to look at the mock HTTP request and response and the multi-part request and response request in order to understand conceptually what's going on. Is this testing only for Spring MVC? Can it be used with other frameworks? Yes, the main goal for this is Spring MVC. But with that said, if you have any other code which is running behind the dispatcher servlet, that can potentially be tested as well, because you have a request and response and you can verify the results. But obviously Spring MVC here, providing built-in support for Spring MVC is the main goal. Question about Spring Security. Spring Security, is it supported? Not directly in Spring MVC Test. Obviously, Spring Security is a separate project. The thing that I pointed out is that filters are supported and that there is a way to use Spring Security here. So look to the Spring Security project and you'll find examples of that. Can it be included in portlets? No. There's no support for portlets. Similar type of framework can be written for portlets, and If you take a look at the source code for Spring MVC Test, it's actually not all that extensive, and it provides a good example of how you would do that for portlets. So if anybody has some free time and desire, feel free to go in that direction. We'll be glad to consider contributions. Is there some way to log the JSON output for controllers as well as to document an API? Yes, absolutely. I showed a slide where you can print all the inputs and outputs, so please refer to that. Is there a best practice for the right levels of testing? I try to touch on that a little bit. Please refer to the slide on strategy for testing. Basically, my suggestion there was to focus on testing the Spring MVC layer and to isolate it from the layer below. So please refer to that slide. Does this testing API, does it come along with Selenium support? I provided a link to an extension for Spring MVC Test that allows you to use Selenium driver API and HTML unit to write tests against essentially a MockMvc instance. So that instead of using a live server, you'll actually just be doing this kind of out-of-container testing. So take a look at that link. There's a GitHub project that you can take a look at, and it's very, very simple. At that point, you'll be writing using the Selenium API to write tests. Does this support previous versions of Spring MVC? Obviously, what's in Spring Framework 3.2 is only usable with Spring Framework 3.2 and higher. But there is a standalone project, and I provided a link to that, and that's usable with Spring Framework 3.1. I already have unit tests with mocking and integration tests with Selenium. Is this just letting me add tests for my @request mapping? Yes, I would say this is a replacement for your unit tests with mocking. You can now write tests that are much more, do a much better job of testing not only your @request mapping annotations, but all the other annotations on controllers, as well as everything else which happens in your Spring MVC configuration and everything else that happens while the dispatches servlet is processing. So essentially, you can think of Spring MVC Test as being a replacement for your controller unit tests. It doesn't replace your integration Selenium tests, but it gives you a much better foundation. By the time you go to write Selenium tests, you can be sure that your Spring MVC layer is working pretty well. Sam, anything from your end?
No, I think that pretty much covers all the basic questions regarding the TestContext framework. Okay.
Well, if that's all, then I want to thank everybody for participating and for all the great questions. And this presentation will be made available on YouTube in the next couple of weeks on the SpringSource dev channel. So watch for that, and thank you once again.